Welcome back. In this lesson, actually in this section, we will start studying geometry. As a matter of fact, we will start discussing what we refer to as circle theorem. Okay, so what is so useful about circle theorem? Uh, the study of circle theorem involves the study of the nature and properties of angles formed inside and outside a circle by lines such as the radius, the chord, the tangents, and the secants. These properties help simplify real-life geometrical problems that would otherwise be difficult to manipulate or solve. Okay? We will look at different areas or different sections of a circle, including these lines, so-called radius, chord, tangent, and secant. We will also be looking at areas within the circle, such as the sector. So the first bit, of course, is for us to know in this first part of the video, we will be trying to understand or to define different parts of the circle and how we will use them going forward in proving some of the circle theorems. We will be looking at about eight to 10 theorems of the circle, and understanding the different parts of the circle is going to be useful. And so we want to ask ourselves questions like, what really do we mean by a circle? Okay, what are tangents, secants, chords, segment with respect to a circle? All right. And in doing so, some of the terminologies we will use, define and use are terminologies like the central angle, okay, the inscribed angle of a circle. What do we mean by an arc? What do we mean by a chord? What do we mean by a segment? And what do we mean by a sector? Additionally, what is a tangent to a circle and what is a secant? We will be defining these terms, but in addition to that, an arc can be minor or it can also be a major. So we will talk about a minor arc and what is a major arc. In the same way, we also have major segments and minor segments as well as sectors. So a sector could be major or minor. So what does that mean? Okay. Let's dive into the discussion then. This is going to be very short. In fact, these videos are going to be, this is going to be a pack of several videos that revolve around the circle theorem. So by definition then, a circle is an outline formed by a set of all the points in a plane that are equidistant from one point. So that one point is called the center of the circle. Okay, so for example, that is the center of the circle, and every point on the outline is at the same distance from this single point that we will represent by letter O. Okay, so a circle then is an outline that is formed by all the set of points in a plane that are at the same distance from the center of the circle. Okay. All right, so that then is the outline of the circle, and that is the center of the circle. Okay, and we can start defining some of the parts of the circle. That is called the radius. And how do we define the radius? It is a line whose endpoints are the center of the circle and any point on the outline of that circle. Okay, the next there, the green line there, represents a chord. And what is a chord? It is a straight line whose endpoints are the outline of the circle. So if you draw a line that touches the circle at 2 points on the circle, then what you have is a chord. And we may, okay, so then what you have there is a chord. Let's move on then. The next is another line. The diameter is actually a chord, but it is a chord that passes through the center. So we say the chord is a straight line that touches the circle at 2 points. And clearly, as you can see, the diameter also touches the circle at 2 points. But now the difference between a diameter and a regular chord is that the diameter is the chord that contains the center. In other words, the diameter is a chord that passes through the center of the circle. Okay? We can also define other parts, other lines that are contained within a circle. And one of them is, of course, the arc, right? So that's called an arc. What's the definition of an arc? It is a section or part of the outline of a circle. If it is a small section compared to the rest of the outline, then we refer to it as a minor arc, which means the other section there, in this case the white section, would be the major arc. So we have a minor arc and the other one is the major arc, right? Okay. Then we have a line that touches the circle at exactly one point. It's called a tangent. A tangent is a line, or sometimes called a ray, that intersects the circle in exactly one point. So it intersects or it touches the circle at exactly one point. Right? Next, we have the secant. So that green line there is called a secant. So the secant is different from the tangent in that the tangent touches the circle at one point while the secant crosses at 2 points. So any line that crosses the circle at 2 points, notice it crosses. So it's different from a chord because the chord has an end point. So the chord ends at that point and at that point. So it doesn't extend out. The secant extends outward. So a secant is a line or ray that intersects the circle at 2 points. Okay? Other than those lines, we also have regions within a circle or areas inside a circle. And the first one there is what we refer to as a segment. Okay, so what is a segment? It is the region inside a circle that is bounded by a chord and the associated arc. So we talked about this here, that outline there, that small part of an outline is called an arc, and the arc together with the chord bound a region within, and that is called a segment. Because it is so we have two segments here. So there is that is shaded in green, and then there is the remaining part. It's also a segment, okay? And for that reason, this is called a minor segment, while the other one, shaded in light green, is what you'd refer to as the major segment, okay? Next is the sector. The sector of a circle is that bit that looks like a piece of pizza. It's a wedge-shaped portion of a circle enclosed by two radii and the included arc. So this arc here is referred to as the included. So the sector includes two radii. That's one radius and that's another one, and that is called the included arc. Okay, and that is how we define a sector. All right, here are some examples. Actually, questions that somebody might ask you. So if you were to be given a question revolving around circle theorem, some parts of the questions might involve requiring you to define parts of the circle. So state what it is and also explain why you think it is. So state and explain whether the line, ray, or segment is best described as a radius, a chord, a diameter, or a secant, or a tangent of the circle. Okay? So you want to state what it is and then explain why you think it is that. All right? The first one here is going to be the line AC. What is the best name that describes line AC, and why do you think so? So your why is based on the definitions that we've given. So clearly, what I want you to do is to pause the video and try giving it a name, and then trying to explain why it is what it is using mathematical definitions that I have already given you. Okay? You can always scroll back, rewind the video to the point so that you understand why this is what we're going to say it is. All right? So AC is in fact a radius. And why is it a radius? Because C is the center and A is a point on the outline of the circle. So line AC joins the center and a point on the outline of the circle. And that is how we define the radius. The radius is a line joining the center of a circle and any point on the outline of the circle. So this is the reason why AC has to be a radius. It's kind of obvious, but the point is, how do we define that mathematically? Okay. Next is the line AB. So again, line AB is obvious. So I think the point here is, can we define what that is, right? So pause the video and try to give it a go. Assuming you've done so, well, line AB is definitely a diameter. But why is it a diameter? It is because it is a chord that contains the center of the circle. Okay, so a chord is a line that intersects or touches the circle at 2 points, and if the chord contains the center of the circle, then that chord is also called the diameter. Okay, so AB is a diameter because it is a chord that contains the center of the circle. Here's the next one, line DE. Line DE, if you can remember that, pause the video and give it a go, state what you think it is, and then try to explain why you think it is that. All right? Assuming you've done so, line DE has to be a tangent because it's a straight line, or you can say a ray that touches the circle at exactly 1 point, and that point is the point B. Okay? The point B is also sometimes referred to as the tangent point. Okay, so D is a tangent line because it intersects or touches the circle at 1 point. All right. How about line AE? Okay, so pause the video and give it a go. And if you've done this correctly, then the line AE, notice it's not AG, it is AE. So the line AE has to be a secant line because it intersects the circle at exactly 2 points, at the point A and at the point G. Okay, and it extends beyond the point A and G. All right. Next, explain why the line AG is a chord. Now we are talking AG and not AE. So the line AG is a chord. We've said this several times now. Pause the video and try out. Okay, so the line AG is a chord. All right, why is it a chord? Because it has got 2 endpoints on the outline of the circle. So AG is a straight line whose endpoints are on the outline of the circle, and that makes it a chord. Okay, next, explain why line BG is a minor arc. So line BG there is a minor arc because it's a small part of the outline of the circle. Okay, of course BG, if we start reading around from the other side, so this is the minor arc BG, but there is also BG going the long way around, and that would be the major arc. Okay, so it's also BG, but it is the major arc BG. Okay, so explain why that is a minor arc. It is a minor arc because it is a portion, the smaller portion of the outline of the circle. Okay, it's a minor portion or the smaller portion of the outline of the circle. Right? Explain why. Region AGBA, which I have shaded now, is not a sector. So for it to be a sector, it must contain 2 radii, and the 2 radii must form an angle BAG at the center of the circle. So since the angle that is formed is not at the center of the circle, this cannot be a sector. Okay, here is my reason written in full. So AB and AG are not the radii of the circle. So for it to be a sector, AB and AG need to be the radii of the circle, which is to say point A is supposed to be at where C is. All right. And the arc BG does not form angle BAG at the center of the circle, which is what I have said. All right, so angle BAG should be at the center of the circle for that to be a sector. Okay, and really this brings us to the end of this part of the study of circle theorem. We have, I think, around 9 more videos to go. They're going to be this short. This is an important section because we will be using these terminologies as we move forward. Okay, please like the video if you found it useful, and consider subscribing. Share it widely with the other students, or share the whole set of videos with the other students who might also find this useful. I'll see you in the second part of this video. All right, thank you very much.